This will be a demonstration of configuring device service clustering the manual way from the ground up, and we'll cover all the setup steps. I'm sitting on a laptop. I'm running VMware Fusion, and I have two virtual machines that I have deployed, and they are started up to the command prompt. Other than that, I have not done anything with them. Now, I will say that this is running version 15, so okay, so this shows up with no license. The other device. Now, I did do one cheat on this when I brought up the device. It does have a management IP address that is static. It's hard-coded, so just want to point that out. But basically, it has been brought up, has a management IP, and the login credentials have been created. So minimum stuff that you're going to need in order to create your initial cluster. You will need a couple of virtual editions or big IP devices, of course, and then you need to have some idea of what your network topology is going to be. So what I will be using is I'll use a 3 VLAN configuration. It'll have an internal and external and a high availability VLAN. The external will be on the 10.14 subnet. Internal VLAN will be on the 10.11 subnet, and that's colored by green here. I have a blue VLAN that I'll be creating for high availability, and then the purple areas are the management IP addresses. So big IP number 1 is at 10.1.1.245. Number 2 is at 246. My Mac, which is running all of this, will join that management network, and it'll have an IP address of 10.1.1.1. It also exposes 10.1.1.2, which is what I'll be using. The Mac is also connected to the network that will run the external VLAN. If you haven't configured that in your VMware environment, you'll need to do that on your own. But this represents the minimal amount of information that you are going to need in order to configure device service clustering. So if I scroll up, I have all these tables. Because this is running on my host, my default gateway, DNS, and NTP are all going to point to my Mac. My management IP addresses are here. The web servers will be running on 4 or 5 different IP addresses. It's all the same machines. This is the interface to VLAN assignment. So external will go on 1.1, internal on 1.2, and the HA VLAN on 1.3. And this is the self IP addresses that we are going to give it. So big IP 1, it will be the 241s. So on the internal VLAN, 10.11.17.241. External will be 10.14.17.241, and then 10.13.17.241 for big IP 1. And then it'll use 242 for the IP address for the self IPs on big IP 2. I will only be creating a floating self IP address on the internal VLANs. That'll be used for passing traffic. That'll be the SNAT address. And then virtual servers. This has nothing to do with high availability, but you need to create a couple virtual servers to even see how traffic groups work. So we'll be creating a couple of those, and then a couple pools. Nothing fancy, just HTTP web servers. So that's the minimal amount of information you're going to need in order to set up device service clustering. And let's go to the big IP. I do have it configured to log in automatically through LastPass, so it's going to do that on big IP 1. I don't think big IP 2 does that. It does not. Okay. So we are logged into both devices, and again, this has not been set up, it's not been provisioned. We will need to go through the entire process. I want to walk you through the high availability wizard, which is right here, to go through the configuration steps. Our aim here is to just get this up and working, but I'll try to talk through some of the things related to the object model as they're applicable. So big IP1's here. The other big IP at 246, it will also say big IP1 until we change that host name, which is important for clustering. Let's get to it. First things first, we'll have to set up the licensing. And I'm going to activate both of these devices, and then I will get back to you. So it took about a minute to get the device licensed, and the next screen you'll be on is the provisioning screen on both of your big IPs. This one's not quite done. Okay, so the license I installed was a local traffic manager license, so we can just leave this as it is and get through it. We'll click next. And then the next one is the device certificate. This certificate is self-generated. It's a self-signed certificate, and this is perfectly fine for doing high availability setups. So just leave this as it is, but if you did want to import a certificate, you can import your own and use that instead for establishing device trust. My recommendation, you're just trying to get through this, use what was provided on the big IP, the self-signed certificate. Click next. And now we need to configure the basic settings. So again, the big IP number 1 is at 10.1.1.245. You can see that was already set up because I configured that IP address manually. You might start up in DHCP. This was pre-configured to go to 10.1.1.245. Network mask is a 24-bit net mask. And then my management route is 10.1.1.2, which is this. It's the host. It's the Mac that's running this. Here's where we set the host name, and hey, I've already got it in my dropdown here, so I'll use bigip1.f5demo.com, and then we will need to set our password. Okay, and keep everything else set at the default. We're just getting this basically running now. Okay, so we've gone through licensing, provisioning, set up the device certificate, which is just leaving it at the default, which is perfectly fine. Setting up your basic platform information, and now we are at the choice, do we want to configure high availability? Let's stop here and go to the other big IP, and let's do the exact same thing. So again, we're on this second big IP device. We're going to just leave it provisioned for local traffic manager. Accept the default certificate that was self-generated. And again, this IP address is static, has already been configured. The route has already been configured. Now we're going to set this host name to bigip2.f5demo.com. Set your root password and click next. So host name's been changed. This one's Big IP2. It's at the same screen as Big IP1. And now we can decide, do we want to do a standard network configuration or advanced? Advanced means you want to do it all by yourself and not use the high availability wizard. We might as well use the high availability wizard the first time. So click next on this Big IP1. And now it's going to say, do you want to go through config sync? Yes. Do you want to go through high availability? Yes. The network failover method, I'm on virtual edition. It's going to be network. Even on a piece of hardware, you're going to be choosing network failover. It's the recommended best practice for configuring high availability. On Big IP2, you can also do the same thing. Click next, and it's here. So if I were to click next, now I'm on Big IP2. I believe it takes you, yeah, it's going to take us through the wizard. So I'm going to put Big IP2 down for a side and start with this first device. So Big IP1. So these things you need to have ready ahead of time. So on the internal VLAN, it's going to ask you, what is your self IP address going to be on that? You need to know that ahead of time. And on this network diagram, what we're talking about is this side of the network. And so this Big IP will use 10.11.17.241. And the net mask, 24-bit net mask here. The port lockdown settings, this defines if you want to lock down this VLAN. Now, this is an internal VLAN, so presumably the external world can't get to it. allowing default will enable the TCP ports that need to be open in order to allow config sync to be established. So set this to allow default. Don't be a cowboy and go on your own. So for this VLAN, you want to leave it at allow default. And then the floating IP, this is the one that would be the SNAT IP address when you start configuring virtual servers. We have chosen, and I think I show it here, yeah, it's this one that kind of bridges the two devices. So 10.11.17.240. Okay. Again, leave the port lockdown at allow default. The VLAN set to internal. The VLAN tag, we'll leave it at automatic. My particular network doesn't use VLAN tagging. And now the interface assignment is going to be for internal interface 1.2. So I'll click 1.2, untagged, add, that adds it to the list, and click next. The next VLAN is the external VLAN. So this one was at 10.14.17.241. Okay, and you'll see this floating IP section. It doesn't have a blue bar, which means floating IPs are not mandatory for your external VLAN. And the reason is because you can have it or not. It's up to you. But what is the purpose of a floating IP on the external VLAN? It's needed on the internal VLAN because of your SNAT IP address. External, not quite as important. I'm going to go ahead and configure a gateway here, 10.114.17.2. That happens to be my Mac as well, but that allows the big IP to route out if we want to. So the port lockdown settings, see how port lockdown is set to allow none. Again, if this is your external network, you don't want the whole world to be able to access it, so you could say allow none. If you said allow 443, you could actually log into this UI using this management address. Let's just leave it at allow none. The VLAN was interface 1.1, or the interface for the VLAN is 1.1. Untagged, click add, and click next. Now the high availability VLAN. This VLAN is a communication channel between the two TMM processes between the big IPs. Now, when you are in a cluster, big IP will communicate over the management address and through the high availability VLAN if you configure it that way. And you really should. You should configure redundancy there to make sure you don't end up in an accidental active-active configuration. So my HA VLAN, the self IP I had chosen is 10.13. That's the network it's on, .17.241. And then 24-bit net mask. And then it didn't give me an option to create a floating self IP. That does not make sense on an HA VLAN. F5 recommends that this be a dedicated VLAN because you only want HA traffic going over this, so you don't run the risk of standard network traffic creating congestion over this VLAN. You want this to be able to communicate freely. So we had chosen interface 1.3 for this VLAN. Untagged, add, and click next. Those were our three VLANs. When you are configuring clustering, of course, when you're making changes, they're supposed to be config synced across. You can configure automatic config sync to do that. Well, that's based on timestamps. So NTP is absolutely essential for high availability. That's why it's posed to you in the wizard. Mine is set at 10.1.1.2. And I'll click next. DNS lookup server. Again, Big IP needs to be able to have a resolver if you're using host names. If you're not using host names to communicate between these two devices, this actually is an optional setting, but I set this every time. Again, I'm going to use my local computer as the DNS resolver. And so I'll add that there and click next. And then config sync configuration. So this is the network address through which config sync will be performed. You can do that over any of these VLANs, but just keep in mind you can choose anyone where you have the config sync port open, which is allowed default on your port lockdown. Now your failover addresses. Because you are following the wizard, it will make some assumptions as to what your failover networks will be. And you should just leave this at the default. This is new in Big IP version 12 and beyond. Prior to that, you had to manually assign these, but this is pretty nice. So it is saying for failover information, it's going to go over the HA VLAN. That is what you want. It's going to be a clean VLAN that doesn't have any other network traffic other than HA. And also your management address. So these serve as a primary and backup to make sure that failover messages or heartbeat messages are passed back and forth. Failover multicast, just leave it at the default and click next. And then mirroring. Mirroring, so much is said on Ask F5 about mirroring, and the truth is if you're just using an HTTP sort of environment, where Big IP is load balancing traffic to web servers, what do you need mirroring for? HTTP connections are very short-lived. They just pass a request and a response, and then the connection gets closed. You do not need mirroring for that. When your Big IP starts doing stuff like SSH connections and stuff that's long-lived, then mirroring starts to become interesting. Regardless of what you choose, as long as you configured an HA VLAN, it will automatically assign that. You can pick a backup, but go ahead and just pick that as your mirroring address. And now you end up at this next place where you need to make a choice. Do you want to establish a pair by discovering another device? Or do you want to go on your own and use the device services clustering menuing system in the UI to do it? We will be doing this, but we don't have another device to discover yet because we haven't configured Big IP2. So I'm going to do this one with a lot less talk. Now on Big IP2, we've reached the same place in the configuration. So we are at the same place here on each of the devices. Now, you can choose to establish your cluster from either one of these Big IPs. I am going to choose Big IP1 to do the initial establishment of device trust, and you're going to choose standard pair configuration, and here you'll click next. And then your options are discover a configured peer or subordinate. It says if you already have configured a peer for this pair, click next to discover the device. We have done that. The other one is configure the peer or subordinate device. So in other words, if you got this far and forgot to configure Big IP2, click finish and switch to the other one. We're just going to click next here and proceed. So here it says discover peer, and it asks for your device IP address. This is the IP address of the management address of Big IP number 2. So basically you're logging in to that Big IP so that you can establish trust. So that is at 10.1.1.246, and my administrator username is admin, and then I'll type my password. And then you click retrieve device information. You see it says step 1 of 3. This will go to step 2. So it was able to contact the device and it found a certificate. It will present the management IP address that you connected with, and it'll present some certificate information. We are configuring these side by side. We know that we're connecting to the right management address, so we can confirm that the device certificate matches. Before I click that, I didn't talk about the difference between peer and subordinate. Quick answer, just click peer. Just choose peer. Peers can also add other devices to the trust group if you have more than 2 Big IP devices. Subordinates cannot. Just pick peer. These are both of your Big IPs. Just keep it at that and don't make it too complicated. So we confirm that the device certificate matches. and it will pre-populate the device name from the one that we connected to, and then it will give a suggested sync failover group name. I don't like this. I will probably call this default sync failover group, just because I don't like the numbers in there. So give it a better name, but you can accept the default. Either way, it doesn't really matter. This will just be the initial sync failover group that it creates for you. And you'll click Add Device. So what this big IP is doing now is it's connecting to the other one, and it's exchanging the certificates so that there's a trust relationship, and they know that they can communicate with one another, even if your admin password changes. So it's establishing that initial connection. And then you're going to see up here your high availability status change to awaiting initial sync. The active status on this one actually changed to standby, so the other device probably negotiated itself as active. Right now they're just choosing among each other, and it says awaiting initial sync. And then you see you got taken back to the welcome screen. So in other words, as far as establishing device trust and an initial sync group, config sync group, that part is all done. So, but it doesn't really tell you much of anything else. So let's see what happened. This can all be found in the device management menu on the big IP. And if you click overview, it should show, it shows that the group, the sync group, is called default sync failover group. That's what I changed it to. There's two devices, and it's awaiting initial sync. The default config sync mode is set to manual, so we will have to do a manual config sync. Right here it says it's manual. We're going to change that. For the golden happy path, I like using auto sync, or it doesn't scale as your configuration starts to get enormous, but I like changing this from manual to auto just to see it working, and then I don't have to keep going here and doing manual syncs. You'll also see that in addition to the sync failover group, there's another group that's created called Device Trust Group. This will be present on every single big IP, and the whole purpose of this group is to sync your certificates back and forth when you are adding devices to the trust group. You will largely never interact with this, but if this does not say green and in sync, it is broken, and you need to start all over again by deleting your device trust group. Nothing works if your device trust group is not in sync, so make sure that is green. You see our two big IP devices in here. This doesn't need to be synchronized. It is done anytime a new device is added or removed from the trust group. Speaking of trust groups, you can find the members also in the device trust members. It'll only show the other member. So here's big IP2. It's a peer, and there you go. So anyway, yeah, we've got that trust group. It's green. This one's awaiting initial sync. We haven't put any configuration on this, so we can choose to just push our configuration over to the big IP. By push configuration, what we're meaning is push our traffic configuration over. Since we haven't configured a traffic configuration, this is pretty easy to do. Another thing we can do, well, let's push this and go ahead and get it in sync, just to watch it. So it'll go red saying they're not all synced. It'll stay red. This does take a few moments. Okay, we've given it a few moments, and it still says not all devices synced. So now, what went wrong? The only indication is that big IP2 did not receive the last sync successfully. You can try it again to see if it makes a difference. In this case, it did not. And so now what's going on? Oh, that's trust group. Why did I do that to trust group? Whoops. So this device says it's online and active and in sync. Whoops, device management. And it says it received the configuration. Oh, a big IP1 did as well. Okay, so after a little bit of drama, and I actually clicked the wrong device, or I clicked the wrong group. I synced the trust group, and because it hadn't pushed the actual config sync over, it said there was a problem. I clicked sync on the default sync failover group, and then after a few moments, it recovered. So I was going to go into troubleshooting mode and look at var log LTM. Didn't have to do that in this occasion. So here we have our failover group was in sync, trust is in sync. So right now, this is all working. So let's explore a little bit what we have. So devices, those are big IPs. We have two that exists in the library for both of these big IPs. Okay, so they both exist. Device groups, this will only show, it won't show the trust group, but it shows the one that we created, and it says it's of type sync failover. You can only have one sync failover group per device. So that's the one that does the traffic and fails over the floating self IP and causes the other device to become active. Let's take a look at this one. So within the sync failover group, it lists the members that are participating in it. So we have big IP1 and big IP2 as part of it. The sync type by default is manual with incremental sync. You can change this to automatic with incremental sync, and you can click update. And this will synchronize itself across. In fact, if I go to this device group, it says config sync mode auto. So that part got config synced over just by setting it to automatic. From now on, anytime I make a change on either of these devices, it will be propagated over to the other device, which is kind of nice when you're just getting set up. Okay, so let's just leave it there. The advanced menu of this allows you to do some extra things like setting how much you want to config sync, and if the network failover setting that's enabled by default when you do that initial HA wizard. So just some extra stuff that you can do there. So that was device groups. Device trust, you should never need to analyze unless something goes wrong. And so if you were to click device trust members and click into yourself, this is where you can take a look and verify that your config sync setting is correct. This is set to the internal self IP address. Failover network is set to my management IP and the internal self IP on the HA VLAN. Notice that this is looking at big IP1. So it's looking at the other device's settings. And then mirroring, again, check that that's set. You can do the same thing on the other big IP if you want to check those settings. Okay, we won't go through those. So device groups, there's two types. There's sync only device groups where you might synchronize something from one of your partitions, where you just want to synchronize, say, policies or something like that. And then there are sync failover groups. That's what this is. It's the default. This is the one that allows traffic to fail over. But what actually fails over? Well, that is called traffic groups. And by default, it gives you a single traffic group. But you can create extra traffic groups, and we're going to actually do that. We'll create, just to demonstrate, traffic group 2. And HA group, we're not going to set that for this basic traffic group. And then failover method, this is why I created it so we can talk about this. HA score, again, this is a more advanced thing. Look this up offline. It's not part of your golden happy path. What we want to do is just preferred device order. Which device do we want to prefer to take the traffic? It would be the first one listed. So we're going to go back to traffic group 1 where we'll see that big IP1 is listed first. For this traffic group, we'll make big IP2 listed first, and it'll take it out. It'll take on traffic by default for network objects that are assigned to traffic group 2. This setting is interesting, and I like to use it just to demonstrate how everything's working. So this one says always fail back to the first device if it's available. This is your failback setting, and by default it's turned off. I recommend turning it on just so you can see how this all works. So what this says is after 60 seconds, as long as big IP2 is available, it is going to take the traffic back for anything assigned to this traffic group. Okay, and we're going to go ahead and create that. And in the list, you can see traffic group 2 has been created. The failover method is HA order, which is the easiest to configure. You'll see that there are 0 failover objects in there, and we'll get into what that means in a moment. There's actually one failover object that exists in this. This was assigned by the wizard. So traffic group 1, this one is, what we need to do is set the preferred order over here, and then we can establish failback. So I put big IP1 first, big IP2 second. It'll fail back in 60 seconds if this device is up, and we'll save it. So what does this mean? It means that if a traffic object is assigned to traffic group 1, then big IP1 is going to be the preferred active device to carry that traffic group. In traffic group 2, where big IP2 is listed first, then it's going to want to, by default, take or put traffic on big IP2. So if you assign traffic objects to both of these, what you can end up with is it's really like an active-active configuration where one device is carrying traffic for traffic group 1 and one is carrying it for traffic group 2, and they're acting as backups as one another. And we will go ahead and configure that in a moment. So this column is pretty important. It shows which device is active for this traffic group, and then what the next active. So because you can configure more than one device with traffic groups, it's no longer active standby. It's active next active. So the next active is configured. Oh, see, it just went. 60 seconds expired. Traffic group 1 switched over to big IP1, and it's active on traffic group 1, and big IP2 is active on traffic group 2. This HA status now on both devices will show active. Okay, so what is that failover object that's assigned? Well, in this case, it is the only network object that we configured, which is the floating self IP address, which is 10.11.17.240. The wizard puts that into traffic group 1 by default. So that's what it is. It's that IP address. If this device fails over to big IP number 2, the 10.11.17.240 IP address would get ARPed on big IP2, and it would use that address instead. That's what floating means. Anything that's floating gets assigned to a traffic group, and then anything that actually is used to pass your traffic, like virtual servers, will be assigned to a traffic group, and let's do that now. So if we go back to this lab, I had said we would use 2 virtual servers, VS1 and 2. They're just going to be port 80 HTTP virtual servers. And so one's going to be at 10.14.17.30. And let's get that created. Quickest path, VS1. Destination address, 10. Oh, it's right there on my list. Service port 80. And you actually, even though it'll be an HTTP virtual server, you don't need to create an HTTP profile. It'll still pass HTTP traffic. You don't need to add that profile in there. But what you do need is you need to configure network address translation if you want that traffic to come back through the big IP, and you would do that if your web servers didn't have a route back to the client. So definitely turn on SNAT. And we want, automap. Not a SNAT pool, set it to automap. Automap means use your self IP address on that VLAN, which will be the floating internal self IP address. Okay, so we've created that, and we really don't need to do anything. Oh, we have to create the pool, and I will do some, let's do some cookie persistence. Because we don't have any pools in the list, we're going to have to use this to create the pool. So we'll go P80 pool. And we use a default monitor of the ping monitor. And then the nodes 10.11.17.11. That's just my list of pool members here. We'll add 3. Click add number 12, click add number 13, click add. We use round robin load balancing. We're not here to explain all the load balancing methods. We're here to demonstrate high availability. Okay, so I have a virtual server. The pool will be set to the P80 pool, and I have SNAT automap configured. That is the bare essentials for getting this working. Oh, I can't configure cookie persistence unless I assign an HTTP profile. Well, fine. Let's do source IP. Okay. Pool member status is red. That's because I didn't boot up the virtual machine that is running those web servers. Let's get that up. So the virtual server is, it's become green because that virtual machine got configured. Let's go to BigIP2, and this is just a demonstration that config sync is working. So on the virtual server list, you see that it got propagated over. But which device is carrying the traffic? And why doesn't virtual server 1 show which traffic group is carrying the load? Well, the answer is there's a difference between a virtual server and a virtual IP address. And it's the address that gets mapped to a traffic group. So here's just to go back, so I clicked virtual address list, and here is that address for virtual server 1, and it is assigned to traffic group 1. So keep that in mind. It's the virtual IP, not the virtual server that gets mapped to a traffic group, right? Think of the virtual server as the config, and the virtual IP is the thing that needs to be ARPed to the switch so that it knows to direct traffic to it. Let's create that other virtual server, VS2. We're going to create a second pool for this, for no other reason than we'll have multiple pools. Okay, that pool has been created. We're going to also turn on persistence. We'll set it to source address also. Okay, now we have two virtual servers. They should show up on both devices. It's already been synchronized. That's the advantage of auto sync. You don't have to keep clicking config sync. Now let's go into virtual address list. So by default, the virtual address gets created in traffic group 1. Now in TMSH, you have the ability to specify which traffic group these go to, but when you're using the UI, it's going to automatically create this virtual address. What I want is this to be in a different traffic group. So I'm going to change this to traffic group 2. Okay, and I'm just going to click update. Simple as that. So the virtual address list now shows that virtual server 1 is in traffic group 1, virtual server 2 is in traffic group 2, and this should show the same thing. It's already synchronized across. If you go to device management just to see the traffic groups again, traffic group 1 is BigIP1, traffic group 2 is BigIP2. They are both going to say active because they're each carrying a traffic group. I can fail over. I can take traffic group 2, click it, and click force to standby. Now this device has no traffic groups that are carrying traffic, so the overall status of this device now is standby, and this one will show active, and it's showing under traffic groups that BigIP1 is the active device for both of these traffic groups. Okay, here's that failover object. That's the virtual IP for virtual server 2 assigned to traffic group 2. This traffic group 1 now has two failover objects. That's the internal self IP and the virtual server 1 self IP. So do you see a problem here? If this virtual server doesn't have a self IP to SNAT over, it might create a problem with the traffic coming back from the server. Let's find out. Let's fail this back over. So you notice when I click force to standby, I'm not forcing the device to standby. I am forcing the traffic group to standby. That's an important concept for high availability. And once again, both of these devices will read active. Let's go ahead and load up 10.14.17.30. And let's do 17.31. And it went ahead and passed the traffic okay. So here it says the client IP address is 10.11.17.242. And here it says it's 240. So we were talking on BigIP1 Big IP1 is carrying traffic group 1, and one of those objects is the floating self IP, and the other one is the virtual address. This web server is detecting that the floating self IP contacted it. That's what this little message here is, 10.11.17.240. 240 is the internal self IP. So web server 1, if I just refresh this, picked up the SNAT address for the floating self IP. Web server 2 is running off traffic group 2, and we didn't create a self IP to float off of it. So we will always use the VLAN's self IP because it's the only one available, and that's 242. So minor difference. We could actually fix that. We could go to self IPs and create an internal floating self IP. So 10.11.17.250. 255. VLAN will be the internal, and port lockdown, allow none. Actually, we can do allow default on this because it's on the internal. And traffic group, floating, but we're putting it on the other traffic group. I think if I were to assign 2, well, it'll probably work, but our whole purpose here is to put a different self IP, 250, into traffic group 2. We click finished, and now in the traffic group screen, they're both going to show they have 2 failover objects. And if I refresh this connection, that changes to the floating self IP. Okay? So what would happen if I were to fail over traffic group 2 over to big IP1? Now it's going to have 2 floating self IPs, right? So let's go ahead and do that. Can I do that from here? No. I have to do it from big IP2. Actually, you can click here, force to standby. Overall device goes to standby because it's not carrying any active traffic groups. Big IP1 is now carrying both traffic groups. So it has all 4 failover objects. Now, if I were to refresh this page, yeah, it still uses 250. And this one uses 240. So some internal mechanism is causing it to use that other IP. Oh, because it's part of the same traffic group, of course. So it's still going to use the self IP that's part of that traffic group, naturally. Okay, does all that make sense? We've been at this about an hour. We've talked about the initial setup from scratch, all the different things that you need to know to provision it. We've created, using the wizard, that sync failover group has 2 devices in it. We configured auto config sync so that when you make changes, it just goes to the other device. And then we added an extra traffic group and put objects in each of them and demonstrated failover among both of them. So let's get this back to its normal default state. Actually, I'm not going to. Before I do it, I just want to talk about rebooting. So when the device reboots, let's say we were to reboot both of these at the same time, it is going to, when it boots, it's going to go to the sync failover group and figure out who the members are. It's going to establish a connection again. And once it does, the traffic groups are going to negotiate based on their settings which device is going to pick up traffic. We happen to be configured with preferred order, which is set to big IP1 primarily, and then big IP2 for traffic group 1. And in the other traffic group, it's 2, then 1. Okay. You could also, do it like this. Have them all be big IP1, and then that would make big IP your normal traffic carrying device. And then if the device went down or something happened, all of the traffic groups would fail over to big IP2. You can also get away with only a single traffic group. Just put everything in one traffic group, and then you'll have a standard active standby configuration. But if you really want to get the most out of your big IPs, if you want to distribute load between the 2 of them for optimal performance, it's kind of a good practice to create multiple traffic groups. That's all I have.